So now in this video, we're going to take a look at resistors in series. The main thing though is that this is a much higher value resistor than that one. It's a 1000 ohm resistor, and that is a 1 ohm resistor. We have 10 volts at the rail there. So we got 10 volts across the two of them. A lot of times when you see me with series resistors, we're making a voltage divider. And ultimately, whenever you have series resistors, you kind of have a voltage divider. But in any case, there you can see the color pretty good there. So that's brown, black, black, brown, and then brown. So brown is 1, black is 0. So we got 1, 0, 0, and then that next brown, we can think of it as 1 more 0 for 1000, or you can think of it as a multiplier of 10. However you want to look at it. The last brown means it's a 1% tolerance. So they claim the value is going to be within 1% of 1000. And these are cheap resistors. I don't think they always live up to that. So in any case, we have this one here. We got brown, black, black, and then you see a silver stripe. So 1, 0, 0. And then a silver stripe means you multiply that number by 0.01 or 1%. And 1% of 100 is 1. So what we're going to look at now is the heat being generated by them, and that's showing up pretty good. You can see that resistor there, and I think that's the wire that you kind of see. I believe that may be the wire, but in any case, you can't see the other resistor. So we can do something. We can it's not hot, we just looked at it, so I can touch the 1 ohm resistor for a little while. Doesn't have to be very long, and now you can see it. It's right there. So yeah, we did kind of see that a little bit before. And then that, I think, is the wire running up there. Yeah. So, in any case, it warmed up a lot by me touching it. So, it was cooler than my fingers. So now, we will turn that off. And we're going to look at what is going on. So, we will zoom back. And I think the light is okay like this. I'll turn it down a little bit. So, the camera seems to adjust to the lighting level a bit when it gets brighter. So we'll get voltage. We will look at the voltage at the rail. I can go to any 2 points that go directly into the rail. There you can see it's a little bit more than 10 volts right there. So this is the 1 kilo ohm resistor. It's got the vast majority of that voltage, 10.12 volts. And we come across this resistor, and there you can see we got 0.01 volts. Now, we got 10 volts, we got 1000 ohms of resistance. Basically about 1001 or so. But 1000 is good enough. But for whatever reason, maybe we needed 1 more ohm of resistance for whatever reason. So, we're going to set the meter to measure milliamps of current, but we can expect pretty close to spot on 10 milliamps of current. And there you can see it looks like about 10.26 milliamps of current. And looks like it's going up a little bit as it warms up. So, but it'll level off at some point. So, we got the same amount of current going through each resistor. When we measured the current, that was the current going through the meter, plus, or not in addition to, but that was the current going through the meter, which was the same current going through that resistor, and the same current going through that resistor. A continuous path from positive to negative, if you follow conventional current. If you want to think of electron flow, electrons were flowing from the negative rail through both the resistors, the meter, and then back to the positive rail, to the power supply, however you want to look at it. But that was the number of moving charges, was 10 milliamps of current, which is the same as 0.01 amps. And so that's what you do when you do Ohm's law. You put it into amps. And so we're going to put that back and measure that voltage again. We saw it was 10 milliamps. So with this resistor, so we'll make the math easy. We'll keep it easy. We'll say 10 volts times 0.01 amps, 10 milliamps, is 0.1 watts. So a little less than 1/8 of a watt. We're going to come to this resistor. Again, it had the same amount of current, and you can see we got 0.01 volts though. So that's 0.01 amps times 0.01 volts. So you think of moving that 2 spots over to the right, and so it's 1/1000th of a watt, and because we got this number multiplied by current, which is the same number, and so very little wattage, very little heat being dissipated. So basically what it's doing is it is very easily moving the energy and the charges through it, because this one is limiting the number of charges, and so it's gathering the voltage across it. So it's keeping the voltage off of this, and so this resistor is carrying the burden of the voltage because it is limiting the current the most. So the power supply has to really work to get that amount of current through this resistor, where it has no problem getting the current through this resistor at all. That's why it is not heating up as much. So as long as you have at least one component that can bear the brunt of the power of the power supply, you don't have to worry about the other components. And like LEDs, that's why you get a current rating on them, because if you limit the current, in this case you want about 20 milliamps or less through these LEDs, as long as you limited that current, whatever's limiting the current is taking the brunt of the power. The LEDs, they basically have no resistance. They have a tiny bit, kind of like this resistor. Now they do light up, and they block some voltage, so they will heat up more than this resistor, but they still don't heat up too bad as long as you stay below 20 milliamps. So as always, make sure to turn the meter off when you're done, and I think this video is done. So thanks for watching. I will see you in the next video.